So, either properties or laws, however you want to think of it. All right, so here's what they are. And these are all ones that you've had before. So if you have exponent here and an exponent here, okay, and then this one, and then this one, oops. I'll go over these, that's why I'm kind of leaving them blank there. And this one. Okay, so these first four are ones that you've already done. So if we're multiplying, right, two quantities with exponents, what do we do with the exponents? Yep, you add them. Okay, so when you multiply, you're going to add exponents. All right. So when we're dividing, what would we do with the exponents? Yeah. Okay, so if we multiply, we add. If we divide, obviously we're going to subtract. Okay. When we're raising them to a power, what do we do with the exponents? Multiply them. And then here, this one's not a whole lot different than number 3. This is going to look like this. So those are ones that you've had, and there's one more that you've had, or actually two. Okay, I'm going to scoot it up a little bit here. Then you had one like this. And then we had one like this. So anything to the 0 power is always going to be 1. And negative exponents. See if anybody remembers this one. So a to the negative n is going to be what? Close. Almost got it. 1 over a to the n. So a negative is going to flip it. All right. So it's going to, if it's 1 over a to the, if it's a to the negative n, then this is going to go, this would be over 1, so it would flip. If it's 1 over a to the negative n, then it goes to the top. All right. So that's negative exponents. So these are all the ones at some point in time you had to have some exposure to them to get to where you are. All right. So the only one that we have left is the one we're going to talk about today. All right. And that is what happens when we have a fraction for an exponent. All right. What does that? What happens then? So let's do that one. Okay. So off to the side here, here's what I want to do. I'm going to take a number, and we're going to take 4 to the 1/2. Let's try 9 to the 1/2, and let's try 16 to the 1/2. So we're going to take our calculators, or you can use Desmos, whatever you want, and we're going to actually figure out what those are. All right, so here's how I'm going to do that. I'm going to take my calculator here, and I'm going to go like this, and I want to check to see if I have a fractional thing. I don't, so here's how I'm going to do this. I have to go 4, and I have an xy right here, x to the y, so I'm going to push that, and it gives me a nice little caret thing. I don't know if you can see it. It's real light right up here. Okay, that's called a caret. And then I'm going to go parentheses, 1, parentheses, now my calculator went away, 1 divided by 2, parenthesis, and it says 0.5 equals 2. I have to hit equals to get it right. So there's 2. All right, now I'm going to try the same thing with 9. So I'm going to go 9 to the parentheses 1 divided by 2 parentheses equals 3. All right. So does anybody right now have an idea what this 1/2 is doing in the number?
It's square root.
It's square rooting it. Okay. Let's check and see. 16 to the parentheses 1/2. So what should this be?
4.
Ta-da! It's 4. Okay. So this bottom number down here, this 2 is square rooting it. All right. Well, let's try some of these then. So let's go 8 to the 1/3, 27 to the 1/3, and see what those are. If our idea is true, then what should be happening here? If it's a 1/3, what do you think is going to happen? Cube root. Let's try it out. So if it's a cube root, then 8 to the 1/3 should be 2. Because 2 times 2 times 2 is 8. And then to finish it off, 27 to the, let's try this out, 1 divided by 3, close it, equals 3. So we're right. I was right. We got cube root. All right. So now I know what this q does. This q, all right, is the root that I'm taking that of. All right. That's what a rational or a fractional exponent does. Now the p, well, what about that? What does that do? That's really not that big of a deal because that just comes here and puts a to the p. Now I put parentheses there, but you don't have to have parentheses there. All right. So that's just a normal power. All right. But the q is the big thing here. This thing here is that root. Okay. Bless you. This p is the power. Q is the root, and this p is just the power. Okay. So believe it or not, that should be the end of our properties or laws of exponents, you know, from the beginning all the way down to the end. All right, so that's what that is. So, now that we know that, we can evaluate some of these things. So if we have, say, for instance, the 4th root of 2 to the 5th. All right, so I'm just going to evaluate this, which means I can use my calculator. All right, and I can use decimals. It doesn't really matter. So here, what I could do is a couple different things. Let's see. I'm going to go 2. Let's write it as a first. Let's write it as an exponent. So this is going to be 2 to the 5 over 4, right? Because it's a 4th root. Okay? 5 is a power. So 2 to the 5/4. So now I can use my calculator to figure that out. 2, oops, I already got 2 there. 2 to the parentheses 5 divided by 4 parentheses equals 2.37841. Thing goes on forever. All right. So we can try another one here. Let's go with a cube root of 5 to the 2nd. Okay, we're just evaluating, just using our calculator. 5 to, what power would this be? What's the root? Right, that's my root, so that's going to be the bottom part. And then 2. Okay? So whatever the root is, that's going to be the bottom part of the fraction. All right, that's it. So, take my calculator out, put this in. See, I really don't need that little root button that we were using before, because now I can just use, I know fractional exponents, so I can put this in. And there are actually some calculators out there that don't have that root option, and you have to use fractional exponents. Okay? What I mean by the root thing is they don't have this square root with a little n there that allows you to input the root. Okay? They don't have that. So you have to write as a fractional exponent. In the assignment, they were just asking you to write the first parts. They're just asking you to write in radical notation, which we're kind of doing already. All right, and they're giving us something like this. Okay, so we're going to write this in, oh, not radical notation. Is that what they're? Sorry, I'm going backwards here. X to the, let's go with 3/4. So to write this in a radical notation, then I'm going to go 4th root of x to the 3rd. Okay. Again, this bottom number here is always that. Okay. Try another one. All right, so let's write this in radical notation. So what's it going to look like? What's the root going to be?
Root 4 x to the 3rd. Or I mean, not.
We're doing this one, guy, here.
Oh, okay. Well, then 5th root.
5th root of
X
x to the 2nd. Yep, good. Good. All right. Even if we had something like this, what would that look like? What root is it? 4th root of 3x to the 3rd. And we're not simplifying anything. All we're doing is just writing them. Okay? We're just writing them. Okay, now they're going to want us to go the other way. Okay, so here we have this. We're going to write this in exponential notation. So it's going to be x to what power are we going to have? 6, 4. Now, question would be, is it okay to reduce that? Yes. It is. Okay? It's okay to reduce that. Okay, here we go. This one's a little trickier. So what's going to be the root? What would be the power on this? What root is it? 3. So then we're going to take a to the 5th plus b to the 5th in parentheses to the 1/3 power. Okay? All right, now we can't, you might say, can we move this inside here? Okay? You can't, because it's a plus. It's not timesing. They're two different things. So just leave it alone. If it was a to the 5th times b to the 5th, then we could go way up to that one of our things, I think, up here that we had. We could use this one, and we could multiply that inside. All right, but it's not that way. There's a plus in there, messes it all up. So we're just going to be done with it right there. Oh, here's one. Again, we're not simplifying anything. Notice all we're doing is just rewriting them. Okay? So, let's do this. So what root do we have on this one? 2. So what's the fraction, what's our exponent going to be? 7 to the bless you. Not 2 over 3. 3 over 2, right? Okay? Because it's the root here goes there. All right? Now, in the back of the book, they might have this. Right? Because you're not really supposed to have negative exponents, but they might say, well, this is the same as 7 to the negative 3 halves, because 7 to the negative 3 halves just flips this. Okay? So they might do it that way. And if they do, that's where they're getting that from. That's your negative exponent. Let's see, we did some of those. We kind of did these. Here, let's just try a couple of them, I guess. It says, write in radical notation and evaluate by hand. Okay, so let's try some of these out. Okay, so we have negative 27 to the 2/3 power. All right. Now we're not supposed to use our calculator. We have to do these by hand, so we have to try to figure it out. So it'd be good for us to know all the cubes. Well, not all the cubes, but most of the cubes. So if we have, for example, 1 is obviously 1, 8 is 2, 27 is 3, 64 is 4. So if I cube 1, I get 1, cube 8, cube root 27, cube root 64, cube root 125. All right, so it'd be nice to have those a little bit, kind of someplace, so you can kind of recognize when we're doing these ones. So, first thing I'm going to do is I'm going to take and I'm going to do the 3 here to this 27. All right. Now, really, it doesn't matter which way you go, but since I'm doing this by hand, I think I'm going to do the root first because I know what that is. So what is the cube root? Because it looks like this. All right, looks like that. So what's our cube root of 27? Negative 3. Now I got to square that. Okay, so what's negative 3 squared? Right. So I have written in radical notation, I put 3 there, I put negative 27, and I put a 2 there. All right? Even though it looks like what we want to do is square this and then cube root, but you could, but it says you can't use a calculator, so we have to go and let's do the root first, since I know what that is, and then square, because then it would be easier. But really, it doesn't matter which way you do it first. Okay, so now here's one with a negative. So it wants me to write this in radical notation. Now, I do have a negative here. All right. So what am I going to do with that 16? 1 over 16. Flip it, right? We're going to flip it. Okay. So that's okay. I can do that. Okay, now I'll write it in radical notation. So what are we taking the root of in this case? What root is it? 4th root of 16 to the 3rd. Okay, again, see, to me, it's like, I want to do this first, okay? Because it kind of makes sense the way it is written there. But, dang, I can't use my calculator, so I'm going to do the root 4th root of 16. Well, let's see, I wonder what that would be. What would be the 4th root of 16, do you think? 2, right, because 2 times 2 times 2 times 2. All right, see, so it's kind of nice to know some of those roots a little bit. Then we're going to take 2 to the 3rd, and that gives me 8. A lot of these are pretty much just writing them in exponential form or back and forth. Here's some here where we're going to simplify. I want 27. Let's pick something different. Okay, so let's try something like this out. All right, we're going to use our properties of exponents on this, which says we're going to go like this and we're going to go like this. So we're basically going to take and multiply these things. So I'm going to write this out, all right, like this, okay. So whenever I have raising a power to a power, I'm going to multiply it. It doesn't matter whether they're exponent or fractions or not. It's all the same thing. So I'm basically taking 4 times 3 over 4. So what happens to the, what's that thing going to be? 4 times 3/4 is 3. Okay, so it's x to the 3rd. So that's done. Now I got to figure out what 16 and 3/4 is. Well, this thing doesn't say I can't use calculator, so I actually could if I wanted to. But I can think of it like this. What's the 4th root of 16? 2 to the 3rd is, there's our answer. So we're applying our properties of exponents, even if it's a fractional exponent, it all works out. Okay? It doesn't change, the laws don't change because of that. Okay, here's one here where we have x to the 2/5 over x to the 3/5. If we wrote this in a radical form, it'd be a mess. All right? So let's not do that. Let's use our properties of exponents. So what are we going to do with these two exponents here? What do our properties of exponents say we do? When we divide, what do we do with the exponents? We're going to subtract them. Okay? I'm trying to get there we go. So I have I don't know why I put a negative 2/5 there. So I have a 2/5 minus 3/5. What's that equal to? Negative 1/5, right? Okay. Oops, wait a minute. I don't want to have a negative exponent. Got to get rid of that. So what is that negative going to do? 1 over x to the 1 over 5. All right. Now I don't have to write it in a radical form. I can just leave it like that. Okay. Doesn't ask me to do that. It just says leave it like that. Okay. So review that a little bit. All right. We've got two exponents here that are fractional exponents. We're going to apply the laws. It says we're going to subtract 2/5 minus 3/5, negative 1/5. Whoops, negative exponent means I'm going to flip that and then just leave it. So we went through that whole section. It's all pretty much just right there. All right, all we're doing is writing them in radical form, okay, and then manipulating that. All right, any questions on anything there that we did? You get a chance to work through them anyway, so. Yeah.
I have a question in the one before. I do understand it's like 2 times, so at the end, 2 times 2 times 2 times 2 is 16. But what happened to the 3? To the exponent 3?
Oh, right here?
Yeah.
Okay, so this is the same as 2 to the third, because 2 times 2 times 2 times 2 was, so the fourth root of 16 is 2, right? Mm-hmm. And then 2 to the third, 2 times 2 times 2 gives us the 8. Okay. Any other questions? Okay. Let's just do a little bit of 5-3 here. Now, a lot of this is, if you took 65, some of this is in here. All right, they just go a little deeper, and the author likes to do a lot of stuff with cube roots and fourth roots, stuff like that. But the premise is the same thing. Okay, so basically, this is going to be operations kind of on radicals. The next two sections would be and the first thing we'll look at is multiplication here. So one of the examples they give is something like this. So the basic rule is when we're multiplying radicals, you multiply the numbers on the inside and the numbers on the outside. And in this case, there's nothing to multiply on the outside. So we're just going to multiply the numbers on the inside. So that would give us 100. Now, they would expect that you would know that the square root of 100 is a nice number. And that's it. So when you're multiplying radicals, we want to multiply on the inside, multiply the numbers on the inside of the square root. Numbers inside, numbers outside. So something like this. Okay, outside, inside. Oops, 12. Okay, outside, inside. Square root of 16, I know that, at least should. Square root of 16 is 4. 4 times 12 is going to be 48. All right, inside and outside. That's the numbers that we're going to multiply to do those. So that's the basic concept behind it. All right. So now that we know that, we can multiply anything. It doesn't matter whether it's a number, whether it's a variable, whether it's a cube root, whether it's a fifth root. It doesn't make any difference. We can do it. So if we have, for example, this.
Sorry, why is 48?
Why is it 48? Because square root of 16 is 4. And then 4 times 12 is 48. So 4 times 12 is 48. So here, we're going to multiply the numbers on the inside. All right, and see it's a cube root, and this is what you're going to run into, which is different than maybe what you had in 65 if you took 65. There was always nice square root things, and you can work through those. These guys are going to be a little bit of cube roots, going to be some fourth roots, so you can kind of see where it helps to kind of know those a little bit. So cube root of 27. I think I wrote that down over here someplace, and they went away. I don't know where I wrote them. I got them somewhere. Anyway, it's 3, and it is a negative 3, and you can take the cube root of a negative, so we did that once before. So there's that. All right, so again, we're just multiplying numbers on the inside. All right, and these ones are turning out pretty nice. If we have a variable, then I'll get you a break here. These are nice square roots. 1, 3. So there's 4. Because we're multiplying, right? And that's going to be x to the second. Okay? So this is a 1 here. 1 here. So we have 1 plus 3 gives me 4. Right? And then x, square root of x to the 4. Now that we know, let me do this real quick. Now that you know about rational exponents, I could rewrite this as x to the 4th to the 1/2 power. Now if I take this and multiply these, that becomes x to the 2nd. So it's almost easier to go this route. At least you kind of maybe understand it a little bit, why this becomes this thing. You had a question? Did you have any? Oh, I thought I saw your hand go up. No? That's all. Oh, you needed it. I just thought you did. All right. Okay, we'll do some more of those. Go ahead and take a break for about 10 minutes or so. Okay, let's see. Back to this here. So let's see, we were multiplying these things, and we did one with a variable. Let's do a cube root because he likes cube roots. So here again, we're going to multiply the inside things. I can't do anything with the 10, can't do anything with the a squared, so that's done. All right. Again, we're just multiplying the inside stuff. Can't do anything. So just leave it alone after that. So we did pretty much some multiplying. Now let's do some simplifying. Now here, again, on the simplifying, it's good to know this stuff here. I'm going to go a little ways. So this would be like n. This is squared. Oops, bless you, 25, 36, 49, 10 cubed, 1, 8, 27, 64, 125, 216, and I think this is 343. All right. So again, he likes to use cube roots, fourth roots, square roots. All right. So I wish I could give you something that's going to really, really help you out, but I don't have any real trick. It's just, you know, it's kind of good to know some of these things. These ones you're probably pretty good at with your mathematical experience. You know, cube roots, you just don't use a whole heck of a lot of those. Fourths, all right. If we did another column, put fourths on there. 1, 16, let's see, 81. 4 times that's 256. And this is going to be 620, no. Yeah, 625, I think it is. Okay, so even I'm kind of getting extended now to where I'm not sure what that is. This is supposed to be 4, by the way. Okay, but why do I need to know this when we're simplifying? Well, because we're going to take and simplify, all right, and it could be a square root, like in this case. We'll do the square root of 32. All right, and there's a difference between simplifying and evaluating. All right, so when you evaluate or calculate, you take your calculator and you go square root of 32, and it gives you a number. All right. Simplifying means we have to break it down, and simplifying tends to be more of an exact answer, where a calculator is going to give you an approximate answer, because you're going to round it, just like we did with those other ones earlier when we had a whole bunch of numbers there. We just rounded it. Okay, simplifying is going to give you an exact answer. So in mathematics, when we're looking for an exact answer, we use things with radicals in them. So here's how this works. We're going to break this down. It's a square root, so I'm going to go to squares. I'm going to find the largest of these numbers that go into 32 evenly. We always want to pick the largest one. All right, so 16 is my largest one. 16 is going to go in there twice. Then I'm going to take the square root of 16. All right, square root of 16 is 4. So the 4 is going to come on the outside. This 2 remains on the inside. And that is simplified. So we find the largest number that goes into 32 evenly. It has to be a perfect square because it's a square root. Find the square root of that number. That comes on the outside. The leftover stays on the inside. That's simplifying. Now that's something, you maybe have seen that before. Okay, let's just do one more. Okay, so we'll do the square root of 75. We can break that down to 25 and 3. 25 is the largest perfect square. It goes into 75. So I'm square rooting, so square root of 25, that's 5. The 3 stays on the inside, so I can't do anything with it. That's simplified. So right now we're doing just square roots. Okay, breaking them down, finding the largest one. Again, what the author of the text, he likes to do some cube roots. So let's say we have a cube root of 54. So we go 54. Well, so I got to find the largest of these numbers that goes into 54 evenly. Right? So 1, well, 1 doesn't do us any good. 8 doesn't go into 54. 27 goes into 54 how many times? Twice. So that means I can break this down into 27 and 2. All right? Cube root 27, that's 3. So I'm going to get 3 cube roots of 2 because that's my leftover. That's simplified. All right, so it's kind of hard to do this because you got to figure out what the largest one and what goes into it, and then you got all your cube roots and whew. All right, but he does like cube roots. Here's a fourth. Okay, 512. All right, so now we got to break this down. So then I go to my fourths. All right, I got 1681, 256, 625. Well, I know it's got to be less than 625. All right, which one of those goes in? What's the largest of those that goes into 512? 256. Good deal. 256 goes in there twice. What's the square root of, or sorry, the fourth root? What's the fourth root of 256? 4. So 4 comes on the outside. That's a fourth root. 2 stays on the inside. Is it 4? 256? Yep. Okay, good. That's done. Okay, so again, we're always trying to find the largest perfect square, cube, fourth root, whatever it is that goes in there. Divide it and simplify it out. Alright, we'll keep going here. We're still simplifying. Now, we're going to do this. Alright, now, good. Well, we're back to square roots. Good deal. Alright, I can do these. So now we take 72. Got to break that down. What is our number that goes into 72 evenly? Our largest one. We're looking at square roots now, or squares. 36 goes in there twice. Okay. Square root of 36 is 6. 6 comes on the outside. All right. Now I have this. Okay. There's a couple ways of thinking about that. One way is this way. So this is x to the 6th. It's a square root, so it's to the 1/2 power, which means that if I multiply these exponents, I would get 3. Okay, that's one way of thinking about it. Okay, the other way is this. This is a 2. 2 goes into 6 3 times. So that would be that. So see, you can think of it either way. It's the same premise, as you can see. This is a square root. 2 goes into 6 3 times. That's that. Or I can think of it that way. Okay? Either way, you got to find your way that makes it work. Okay, so now this x to the third is going to come on the outside, but I still have this 2 here on the inside, so I leave it, and that is done. So I found the largest number went into 72. It's got to be a perfect square. 36. 36 goes in there twice. Square root of 36 is 6. That pops on the outside. 2 stays on the inside. I take the x to the 6th. I can either divide it by 2 because it's a square root, or I can think of taking it to the 1/2 power. Cube root. Let's go with a negative 16 x to the third, y to the fourth. All right. Getting a little harder. We got a cube root. We've got 3 x to the third, y to the fourth. All right. So we got to find the largest cube root that'll go into 16 nice and evenly. What goes into 16? 8 goes in there twice. It's a negative. That's okay because we can do odd powers of negatives. What's the cube root of 8? So I'm going to take the negative 2 to the outside. All right. I got a cube root and a 2 there. Okay, now, same thing. I can think of this in a couple different ways. All right. I can take this 3, divide this 3 here. Okay, this 4, divide by this 3. Or you can write it as a fractional exponent. So this 3 divided by this 3 gives me x to what power would that be? X to the what? 3 divided by 3 is just 1, right? So x to 1 comes out. Okay, you say, well, what about this? Okay, I got a 4 and a 3. 3 doesn't really go into 4, and it doesn't. Right? It doesn't go in there nicely anyway. It does go in there once with a 1 left over as a remainder. So what happens then is we take this y and we would write it as y to the first power because it does go in there once. But because there's a 1 here, that means there's a 1 left over on the inside of the radical. Alright? I think that's the easiest way to think of these, is to actually perform this division. But it comes from that idea of the fractional exponent. Okay? Because if you try to do the fractional exponents with this, it's not going to give you this idea here. Right? So let's try another one, something like that. Cube root. Let's go with 250 x to the 6th and y to the 5th this time. Alright, no negatives. So I gotta find the largest cube root. Goes into 250. Did we find one? 125 goes in there how many times? Twice. Good. So the 125 cube root, what's that equal to? 5. That pops on the outside. Cube root. Alright. 2's left over. That's got to stay. Now we're going to divide these. What's that power going to give us there? Oops, I got a little excited here. Put the 5 too close. 5x to what power? Second. Okay, what about here? This one here. Oh, come on. And this one here. So 5 into 3 into 5 gives us, how many times does it go in there? Once with 2 left over. So one of the y's is going to come out. Alright, but I got y squared inside because it's a remainder of 2. Okay, so that's a little bit tricky. You want to see another one like that, or are you kind of seeing how those work? Again, this is, well, you can always practice some of these, I guess, too. Okay, I'm just kind of looking down here as I'm going through the book here. Now it says, what about if we have something like this and something like this? Okay, what do we do then? Right. Well, how is this one different than the ones we were doing before? How is this different? Yeah, we got a square root and a cube root. Okay, so before I said, well, hey, all you got to do Just multiply the inside thing. Multiply the in, multiply the out. Problem is that both of them were the same root. These ones are different. That messes everything up for us. So what strategies? Here's what we got to do. We got to take this and write it as 5 to the 1/2 times this as 5 to the 1/3. Good thing these are both 5s because we need that. What do we do with these two exponents when we multiply? What do we do with these exponents? Add them. Right. So now we're going to take 1/2 plus 1/3. Okay? So 1/2, I got to get a common denominator there. What's the common denominator going to be? 6. How many 6s 1/2? How many 6 would 1/2 be? 3. So we have 3 6 plus 2 6. So we're going to get 5 to the 5/6 power. Right. That's what that's going to look like. All right. It says here in the example that they want us to write it in radical notation. So that means I got to convert this into a radical notation. So what would be the power on the radical? All right, and then it's just going to be 5 to the 5th. Now they might do this, and I got to figure out what 5 to the 5th is. Oh, well, of course I closed out my calculator. So 5 to the 5th. I got a nice one here somewhere. There we go. 5 to the 5th. Somebody's probably got it already. Now I'm trying to search here. Oh, there it is. 3125. Okay. So either one of these answers is acceptable to me. It doesn't matter. I'm more interested in that you can actually do that. So when these things are different, then we got to get that common denominator. All right. Let's try another one. This is going to be 3. This is going to be 4. Okay. So again, we can't multiply those because they're different powers on the roots. Can't do it. I got to write them as fractional. Now I need a common denominator. What's going to be my common denominator for the 1/3 and the 1/4? 12 is my winner there. How many 12ths is going to be 1/3? 4, right? How many 12ths in 1/4? 3. So what's my power going to be here? 7/12. Okay. Oh! Seriously? There's such a thing as a 12th root? Oh my goodness. There we go. All right. But the idea is that you can't see. I think the rationals was the hardest thing I thought we were going to do. These things aren't real hard. It's just a little hazy because you've never done stuff. So you kind of need, well, you know, you can multiply when they're the same. Now if they're not, I got to do something else. And I get these little fractional exponents all of a sudden. So that's kind of what makes it hard. Is that there's a lot of little rules, you know, mathematical rules or whatever, procedures that you kind of got to be careful of when you're stepping through these. All right, makes them a little bit more difficult than just straight up ones. Let's see if there's some things I haven't done yet. 361. Oh, we should be okay there. And I think we're going to be okay. Everything there we covered. Alright. So, let's stay the course. So I'm going to let you work on these problems here. Zoom that. All right. So continuing with operations, we did multiplication. So we'll do addition, subtraction, which follow the same rules. And then division. Okay, so 5.4 this is. So adding and subtracting these things is very similar to fractions, I like to think. All right, so when we are adding and subtracting, I want to get on the right page here. When we're doing fractions, we're okay as long as we have like a common denominator, right? So we get 4/5, okay? Radicals are the same way. We're okay as long as those things are the same. Whatever's underneath has to be the same, okay? And of course, the root has to be the same. All right, we can't add things that have different roots. It doesn't work. All right, so we can't do a square root and a cube root and add those things up. All right? But we can as long as they stay the same and these numbers underneath are the same. So if we have this plus this, that's going to give me 2 of those. So very similar to the fraction where we had 1/5 plus 3/5 equals 4/5. This one, if we have a square root of 5 plus a square root of 5, we're going to get 2 square roots of 5. All right. If we have a square root of 5 plus 3 square roots of 5, we're going to get 4 square roots of 5. So it's very, very, very similar to the same. All right, very similar. So that's the concept behind it. All right. So when we're adding things or subtraction, doesn't make any difference. We got to get the same thing in the denominator. So if we have, again, here's another one, 2 square roots of 3 plus 4 square roots of 3, what are we going to get for an answer? 6 square roots of 3. We don't add the numbers inside the radicals because we're not multiplying or anything, we're adding. So it's very similar to a fraction. 2, 4, 6. 2 square roots of 3 plus 4 square roots of 3, 6 square roots of 3. All right, that's what we're going to get. If they're not the same, then we can't do anything with them. So if we have something that's a square root of 8, all right, plus a square root of 15, I can't do anything with that. All right, they're not the same, so we can't add them. It's done. This is done. This is done. Can't do anything more with it. All right. Now we could have a situation where we have the square root of 24, okay, plus square root of I got myself into a bind here. 54. Okay. I can't add those because the what's underneath the radicals aren't the same. But this can be simplified, and so can this. What number goes into 24? That is a square root. The largest one that goes in there is 4 goes in there how many times? 6. So this is 2 square roots of 6, right? Okay. Plus, what one goes into 54? Largest perfect square goes into 54 evenly. 9 goes in there 6 times. So this would be 3 square roots of 6. Now look, they are the same, so we can add those and get 5 square roots of 6. So if they can be simplified, then you have to check that and see if you can add them, right? If it's 8 and 15, there's really nothing I can do with 15. I can break 8 down, but still I'm not going to get anything. But here, 24, 4 and 6, 54, 9 and 6, that one's going to work. And what he does with these is, of course, he does cubes. Okay, so guy likes cube roots. So we have a cube root of 16 plus 3 cube root of 2. Right? Well, normally we'd say, well, I can't add those because it's a 16 and a 2. But you can break the 16 down. Right? You got to find the largest cube root that goes into 16. What's the largest cube that goes into 16? 8. 8 goes in there twice, right? Good job. So then the cube root of 8 is, so we have 2 cube roots of 2 there, 3 cube roots of 2 here. So what's our answer going to be?
5 cube roots of 2.
That's correct. All right, so you know, I wish there was some way I could, besides giving you that little chart, of a way to know those perfect cubes, but there isn't. There's no trick. You just kind of got to know them. All right, you just kind of got to know them. The nice thing is I don't see any fourth roots. Good for him. Okay, he just gives you cube roots, right? Oh no, there is one. Oh my goodness, there is one. Gosh. I think it's one we have to do. Let's just do it. 45. I don't know whether they were just trying to make this section harder or something by putting this junk in here. Or what? Okay, so now we got fourth roots. Alright. Chances are, I mean, they're telling you to simplify them, so they're probably going to break down, right? They're just not going to do that, but alright, so let's, nice, at least they did the 3 for us. And most likely, 3 is the one we want, right? So 3 times 4, or 3 into 48 is probably going to give you the, it's probably going to give it to you. So we know this is probably going to be 3. 3 goes into 48. 16 times, good. Okay. So 16 is probably that largest. Normal if we go backwards on it, but since we know it's going to work, most likely 3 times 16 is what we want. So let's see, 4th root of 16, what's the 4th root of 16? So we're going to get 2 4th roots of 3 plus 4 4th roots of 3. Going to give us 6 4th roots of 3. Alright, so I did that one for you. Saved you the pleasure there. Alright. Well, here's some kind of interesting ones. I'm doing some of the ones off your assignment for you. Okay, so now they put some variable stuff in there. Oh my goodness. But it's going to work the same way. So we have square roots, at least they're not cube roots or fourth roots, they're square roots. So I can factor this, right? How, if I factored this, what would it look like? Square root of what are we going to have? 9 times
X plus 2.
right. Okay, minus, what about this one? What can we take out of that? 4 gives us x plus 2. Okay, so square root of 9? 3. I can't do anything with that, so I'll leave that inside. Minus square root of 4? 2. Can't do anything with that. Right? So now what's our answer?
X plus 2.
Yeah, we just have 1. I'm going to put a 1 there for the heck of it. Okay, x plus 2. Alright. So in those ones, we factored it, and it just turned out 9 and 4. How about that? Alright, and then, so, but the idea is the same. Just normally, you'd have numbers instead of a variable there. I'm checking to see.
So then
I didn't even give you that one. Oh, it's a free one.
for like number,
Oh, maybe I did. Yeah, I did. What's up?
for like number 24, that one that
Yeah.
I'm asking about 8 minus
Mm-hmm.
4 roots of 30.
Mm-hmm.
You have to take it out of the root 3 or something.
Can't do anything with it. It's done. You can't simplify those because there's an 8, which is just a number, and a radical. And they're not like terms.
Yeah, I thought maybe you could like turn the 8 into
Square root of 64, but then still you wouldn't be able to do anything with it.
Yeah.
Mm-hmm.
Cool.
Yeah, that's what it is. Okay, let's see. Oh, how about some of these? I looked at these ones, and he didn't have any cube roots here, so that was good. This is straight out of Math 65. Here, I'll make it a one like this first. All right, so here we're simplifying still. Oops. We're simplifying still. All right, so we can just, what we're going to do here is FOIL this. Right, which probably makes sense to you because that's when you have double parentheses, that's what you do. So we FOIL, 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 FOIL. 3 times 2, that's 6. 3 here. 2 there. And multiply the inside. So we went, right, 3 times 2, that's 6. 3 times the square root of 5, so that's 3 square roots of 5. This is an outside number, this is an inside number, so we don't intermix those. Same thing on this one, right? This is an inside number, this is an outside, so we don't mix those. Multiply that, and we get square root of 25. So I get 6 here. What is this going to combine to? 1 square root of 5, right? What's the square root of 25? 5, so I go minus 5, and now I can finish this like that. So when we have double parentheses like this, we're going to just go ahead and FOIL it. All right, anytime you have double parentheses like that, you FOIL. Same thing, we're just going to FOIL 6. Now here we have an outside number and an outside number, so we're going to multiply those two only. Leave that alone. Here I'm going to get to 5, but I have a square root of a and a square root of a. So I'm going to write it like this for now. Right? So then I take 3 times 2. I'm FOILing this. 3 times 2 is 6. 3 times this gives me negative 15 that. Okay, because outside number, nothing here. Here I have an a and a 2, but this is an inside, so I can't multiply those two. I just leave it. Here, I don't have anything on the outside, so it's a 5. Square root of a times a. 8 times a is a squared. And now I'm going to simplify this. So what do we get on the, what is this all going to combine to on the inside? What do we get there? Negative 15. Negative 13 square roots of a. This, okay, this, I get a negative 5. Oops. Right? But what is this going to change to? A. All right? So look, now I can't do anything, so this is done. So I have 6 minus 13 square roots of a minus 5 square roots of a. I can't do anything with that. Nothing else combines.
Minus 5a.
Right. So we can't do anything with it. All right. Done. But the main idea is FOILing. Okay, so whenever you have, again, double parentheses, you're always going to FOIL. All right, so there's a couple of those. Questions on, let's see, anything we've done so far with this? We only got one more to go. But any questions on adding, subtracting, foiling? Probably pretty good at foiling because you guys do it so much. One last thing here. The last operation is division. When we do division, we don't really call it that. We call it rationalizing the denominator. So what does that exactly mean? So if we have 3 over the square root of 5, right, this means division, but we can't divide those. One of the rules of mathematics, for those who are going on to 111, and you start doing some trig stuff, all right, you can't have a radical in the bottom of a fraction. Okay, so whoever is your instructor is probably going to say that. You can't have a fraction or a radical in the bottom of a fraction. So you have to rationalize it. Well, here's how we do that. We're going to take the bottom and the top, and we're going to multiply it by the square root of 5. Okay, and it's easier for me to do it than explain it. So on the top, again, we don't have anything we can multiply there. Here, we're going to get the square root of 25. But what is the square root of 25? Okay, so we say that this is a rationalizing because we're taking two irrational numbers and making them a rational number, because 5 is a rational number. So when you have a square root down here, you can't have a radical or a square root in the bottom of a fraction. So you multiply by whatever makes this work out nice. Right, so if we have a square root of 5, we're going to multiply by that. Okay, now I get the square root of 25, which is just 5. So that's done. But we're not really dividing anything because you can't. Right, you just rationalize. So if we have something like this, oops. Okay, so if we have something like this, I'm going to split this up, first of all, into the square root of 5x over the square root of 12. All right, so now I'm rationalizing, so we're going to multiply the top and the bottom by the square root of 12. So what are we going to get on the top? Let's do the top first. Let's multiply the inside numbers. What's that going to be? 60 and an x, right? Bottom's easy because we're setting this thing up. So square root of 12 times the square root of 12 is just going to be 12. Okay, so that's done. All right. Now you might think you're done, but most likely it's going to say simplify, rationalize. Okay, this 60 can be probably broken down. I wonder if there is a perfect square that goes into 60. We should check it out. So what's our largest? Let's see. Let's check 4. Does 4 go into 60 evenly?
Yeah.
How many times? 15. So that's our winner. So 60. 4 goes in there 15 times. Alright. This is 12. So, square root of 4, or square root of 4 is 2. 15 stays on the inside. X, we can't do anything with that. You think, aren't we done with this yet? Nope, because we can reduce this fraction. There we go. But the idea is you're just always multiplying by whatever's on the bottom so we can cancel things out. That's called rationalizing. Let me do one more of those. because I see one here. Okay, whoops, let's not do that because those are going to reduce. There we go. All right, so we're going to rationalize this. Okay, I have a 5 root 7 on the bottom. The 5's okay. We don't need to worry about that. What are we going to multiply the top and the bottom of this by to rationalize it? Square root of 7. Good job. We get 4 square roots of 7 on the top. Okay? What are we going to get on the bottom here? What is this going to give us? So we're going to 7 times square root of 7 times square root of 7 is just going to be 7 times 5, 35. Okay. That's rationalizing. All right? So we went through all operations: addition, subtraction, multiplication, foiling, division, which is just rationalizing. Questions on anything there that we did? Or anything? Questions on anything? Anything from the stuff that anything that maybe you confused about from before? Okay, so even if there's some things you want to talk about afterwards, I kind of purposely set a little bit of time in case you had some questions from the assignment that was due when I wasn't here and you wanted to get some questions on that. I'll be happy to be here to do that for you. Okay.